It is 9:30. So maybe we'll let people straggle in because I'm sure that Thursday morning is not the most. We get the blue sheets. All right. So blue sheets are going around. Hopefully you know what to do by now. If not, ask your neighbor. Welcome to Avtcore. All right, so yeah, we have Magnus Vesterlund taking notes in the Etherpad. If you feel like going to the Etherpad and watching what he writes and seeing if, adding any additional things that you think are worthwhile, that'd be appreciated, but it's not strictly necessary. You have Brian Rosen in the Jabber room. If you're remote, use the Medico queue, the virtual queue if you're able, and we'll push our fancy red button and get you up on the big screen. But if you'd rather have Brian talk for you, you can do that too. Was there anything else on the video? Okay. Oh yeah, blue sheets are going around, and there's Medico if you want to watch this later. All right. Note well. Ask your lawyer. So today we are nominally going till 11, but I think DMARC, which was in here, is supposed to be in here after that, is canceled. So if we run over, it's not a big deal. I hope nobody scheduled something for 11 as a side meeting. As it says, I'm Jonathan Lennox. This is Rachel Fung. Did I pronounce your name like that? Rachel's doing something to the slides. What are you trying to do? Oh, it's full screen. It's full size up there. Oh yeah, this is just giving you a preview. Oh no, yeah, no, I can see it here too. So, yeah, okay, and then so we're starting with our new work item, RCP feedback for congestion control, which we Yeah. No, I was just looking around. Which we agreed to adopt last time, and I finally actually managed to submit a request a milestone for on the week before the meeting. So, but you did, yeah. After that, we're doing frame marking, which hopefully we can finally get done. That's been lingering rather too long. Then Ronnie has a proposal for an extension to that. Then Colin is presenting some stuff on how to do quick multiplexing with RTP. And then finally, because XR Block isn't meeting, there's a presentation on a proposed new XR Block, a message mostly for socializing the idea and getting feedback on how it is, because obviously we can't adopt something on behalf of XR Block, but he wanted to get feedback on what people thought of it. And finally, if anybody has anything else to talk about. Okay. So last time we
Ronnie, I just want to take the opportunity, since payload is not meeting, there's the FEC draft payload for FEC, for flexible FEC and we are going to start, we are hoping to start a working group last call since there's dependency on RTC web. And I would like to take the opportunity that people will pay attention. I will also try send it to the RTC web and the payload, but they should review it. Maybe I should also send it to Avtcore, so at least the people who are not following those working group, they'll know about it and start and review.
Yeah, feel free to advertise it wherever you think is appropriate.
Right, and for this is Adam Roach. For the people in the room, I want to point out this is a dependency for cluster 238, so there's going to be a lot of heat on getting this completed fairly quickly.
All right, so I think here you see we've done our parts on getting things actually published. This may have actually been part of 238. I'm not sure. So. I think at least new header extensions might have been, but I'm not sure. What? Anyway, yeah. So I think, but then yes. So we've had 3 documents published. coming out of the RFC editors queue since last time. So yay us. And then we still have a number of things which, as you see, are still in the queue, 3 of which are part of 238, waiting on bundle and possibly other stuff, but bundle seems to be the primary thing listed. And then we have 1 document which is waiting on ourselves, so let's get frameworking done, so at least we don't have that hanging over us. Other than that, so multipath RTP, is York here? He was mentioning it last night, but I don't know what he said he hoped to do some work on it sometime, which wasn't terribly encouraging. So yeah, the thing I'm trying to, I'm not quite sure what our milestone is for multipath RTP, but I think it's like 2016. So I feel like maybe we should do something about that. But on the other hand, if we don't know, if we have no idea, I'd rather make it obvious we missed it.
Ronnie, I mean, it goes a longer time back. I mean, we moved it already a couple of times because we are trying to figure out if they're going to work on it. And this, York says that they intend to, so we're waiting. I mean, I don't know what to do.
At a certain point in time, one has to decide whether a milestone should die.
Yeah.
I mean, in the abstract, I'm not.
In the abstract, I know. Yes, and then multipath RTP is that thing that's just on the edge, permanently. Yeah, it's always showing like just the slight, Yeah, I don't know. If York were here, we could ask him. Or any other authors? So yeah, I don't know what to do about that.
Flip a coin.
Yeah.
You can always add it back.
That's true. I mean, my temptation. I mean, I will try to see if I can get any more concrete commitment out of the authors, but if not.
Jared, I think what Ben said, like maybe we can take it later, and if it is more important, because as I say, like there have been some work proposed for like RTP who are quick and stuff like that, and that certainly changes some demography when it comes to multiple RTP and stuff like that, right? So actually I don't feel any interest in it, so just for the record.
So yeah, I will, like I said, I think I will try to see if I can talk to the authors some this week and maybe send out a list saying, if we could put this in. We'll take the milestone off, and if somebody is interested again, we can always put it back on again.
This is Ben. Feel free to tell the authors that the area director is asking why we shouldn't kill this.
Okay. That's more concrete.
Because he is.
Okay.
So you'll be the bad guy, right?
That's part of my job.
And then multi-fact guidelines, we have a slide on, and all the other working group items have at every time. So multi-fact guidelines, Ronnie, do you want to talk about this?
This is also one of the documents that was standing there for a while without a milestone, not continuing. So we took it to finish this document. So as you see, the 03 version was submitted in October 2014, and Marvin and myself did editorial changes on the document because it's mostly editorial changes to the structure, and based on discussion we had with Magnus before about what should be done, because Magnus and Colin were the previous authors of the document.
Don't call us previous author. We are still authors.
Yeah, no, of course. They are still authors, so the editors, right? Sorry about that. Sorry about that. Okay, so they're still the authors of the document, sorry. The 04 and 5 are big editorial changes in the document structure. It's updated to reflect the current state of multiplexing documents and options, which were changed between 2014 and today.
Look like you also aligned it with taxonomy.
Yeah, we tried also to do that. I mean, we tried to do everything to keep it up to date to the current documentation, which said like simulcast, things that were added during the time from then. It's not ready for publication. The 4 and 5, they're not. I mean, the reason we had the 4 and 5 because on the 4th there was some typos that was there, and it was just a change of typo. But if you want to compare to previous, then you have to compare it to 3. And I think Magnus put it on this diff on the mailing list. It's not ready for publication. There are some open issues based on the review from all the authors in section 7, and the next step is to update the document to reflect the open issues. It was reviewed only by Colin and Magnus, the co-authors, and we'll need more reviewers probably for the next version.
Does anybody want to say that they'll do a review of this document? Any volunteers? Everybody stares firmly at their laptops. I mean, honestly, Colin, Magnus, running, and probably myself is a pretty good subset of this group anyway. It'd be nice if I had somebody outside the usual suspects. We'll do it again. All right, so I think that's the last share slide.
After the,
Oh, well, Mo is volunteering, but Magnus right down the ball.
after Daniels from ADs.
Yeah.
Yay.
Yes.
I'm not AD in this group. I'm.
I didn't say responsible ADs.
Yeah. I remember when we only had the responsibilities.
Your memory goes further back than mine.
All right. Okay, yeah, so first it would be conditional. No, that's that.
I think we
You're doing congestion control? Oh, I thought you were, oh. Oh.
just the mic towards you.
Higher.
Probably higher, right. Okay, that's broken up completely. Okay, this doesn't, the mic doesn't go higher, so we'll have to hope this works. Any adjustments? There. This is just going to break, so I will just. Do I look like a rock star? Oh, okay, Phil Collins maybe. All right, hi. I'm right. The banter is being recorded for posterity, right? Yeah. Okay, so I'm Colin Perkins. I'm going to talk about the feedback message draft. Next slide, please. Okay, so this was something we presented at the last IETF. It's come out of the RMCAT working group. We had a design team devising a RTCP feedback, or a couple of RTCP feedback formats to carry the information we need to do congestion control, and that will be able to drive the congestion control algorithms that RMCAT is developing. We presented the design team version 03 of that draft at the last meeting. That was then revised to take into account the comments from that meeting shortly before this meeting. And then the Avtcore -00 draft was submitted about 6 hours later and is identical apart from the file name. Next slide. Okay, so the change the primary change we've done this time, the previous versions of the draft had two different feedback formats. They had an XR block for regular reports, and they had a transport layer feedback packet for early feedback reports, which could be sent in non-compound packets. The feedback we got from this group at the last meeting was that this was unnecessary and we should just use a transport layer feedback packet for everything and just put it into a compound packet if we were using it as our regular reports. So the change we made was essentially to take out the XR block format, leaving just the transport layer feedback packet formats in the draft. And the transport layer feedback packet format is exactly the same as the one we discussed before. We've just taken out the alternatives. There's now only one way of doing it. As you see, it starts with a common header with the usual RTCP things and the SSRC of the sender. There's then a series of blocks which have the SSRCs of the media source they're reporting on, begin and end sequence number ranges, and then for each sequence number there's a 16-bit chunk which has a single bit to indicate if the packet was lost, which if set to 1 if the packet was lost, and then the rest of the 16 bits are then meaningless. Otherwise it's set to 0 and you've got the ECN echo and the arrival time offsets relative to the report timestamp at the end of the packet. We put the report timestamp, which all the offsets are relative to, at the end because the transport layer feedback format says that everything has to start with SSRCs. So we're just conforming to the usual style of those. And yeah, and you just stack a bunch of those and then you have the report timestamp at the end. So the changes for the draft are just to keep this format, take the other format out, and fix the IANA considerations. Excellent. So next steps. I think primary open issue we have is just quite how the timestamps work. I think the draft is currently specified to use milliseconds for arrival time offset and is a little vague about the report timestamp clock rate and the format, and we need to align those to the extent possible and pick sensible rates and sensible formats. What I think would make sense for the report timestamp would probably be to use the middle 32 bits out of the NTP timestamp, just like we do in the LSR field in the sender reports. So we're using the same clock we already have for our TCP. That doesn't quite line up nicely with the millisecond which we've got in the arrival time offset, so we might need to change that. If we count 1024 hertz instead of 1000 hertz, that then lines up nicely. It's a little bit of a nuisance, but so we'll have to think a little bit about that. But I think we can do something sensible there. We should give it a little bit more thought. We then need to review the candidate congestion control algorithms in RMCAT, make sure this fits with what they need and gives the right information, has acceptable overheads and so on. Define some SDP signaling for it, and go through and do some editorial cleanups. Other than that, I think we're in reasonably good shape. And as I say, that the main issue is figuring out the timestamps.
Magnus Westlund. So, having reviewed the document but not sent any review, I think the main thing I think needs more work is discussion of how you adapt the transmission of this when you send it, and kind of so.
So that's actually a separate draft which we have in RMCAT. That will be the.
Will that be CC agnostic?
So the way I was envisaging this was that it would just define the format, and then the RMCAT draft would say, this is how you pick the feedback rates and configure RTCP to be appropriate for your congestion controller.
Yeah, I mean, considering the goal of having this being kind of agnostic to what sender side congestion control algorithm it's needed, I think we need to ensure that you have both the kind of type of scaling and the kind of reporting, because I think that you desire in a receiver behavior is well defined.
Yes.
And it needs to be, if it's going to be in the RMCAT document, that's probably needs to be a normative reference then. And so, I mean, it's if you pick, it depends on from which part you're coming here, but I think it needs to be clear that this is defining a very important piece in that case for this format.
Yes, I mean, I'm not sure it's normative in quite that way. I mean, I think all it will specify is you configure RTCP bandwidth fraction using the existing parameters as appropriate for your congestion controller, and it will give some guidance for how you do that. And I think what will actually happen is the candidate congestion control algorithms will say, use this feedback format and configure your RTCP bandwidth appropriately, according to the media rate you have, and there are some guidelines for how you do that and signal it over there.
Okay. Yeah, I need to think a little bit more about that. But yeah.
But I think how you configure the rates is independent of the format. So yeah, we should possibly
Yeah,
put something in that says you need to configure the rate appropriately. But I don't want to have that discussion in this document.
So I mean, I think part of my thinking was maybe a little bit more not only to there are cases, I guess, where you have, okay, when are you actually sending this? Are you including it even if you see 0 new packets during the reporting interval? So, and things like that. There's I think a few questions around this saying when you're having sparse or maybe overfull mode.
That's true. Yeah. Okay, that's a good point.
Jahed, what I think, like this draft just only says like this is the format, this is the information you need from receiver to sender, and this is the format, and the real implementation of like how and how, like when and how frequent they are sending, and the candidate algorithm need to decide on that one. So my expectation is like they take this and implement this and tell us like whether what kind of configuration is working for them, because the current draft currently says like you can negotiate the rate, sending rate, and stuff like that. So that is my expectation, and I'm not quite sure like
specific. That's congestion controller specific.
Yeah, that's congestion control specific. So I don't know like how we can in this draft actually say we can perhaps write something about recommendations like, okay, this is what we think, but they really need to say it in there how they're implementing.
So as I say, I think this draft shouldn't say much, if anything, about that.
Yeah, exactly.
It should say it needs to be configured.
Yes, that's what it says right now.
Yeah, there's an RMCAT draft that says, this is how you go about configuring it based on your requirements and what makes sense. And then I think the candidate should say, for this candidate, configure it in this way.
An informative reference to the RMCAT draft would be appropriate.
Yeah, okay.
It says, you must configure it,
and then here's some guidance. Yeah, sure.
That I think I agree with. Yes,
sure.
Yeah.
It will mean those two drafts then go in lockstep because they'll reference each other, but that's okay.
Mosinati, real quick, Jared, can you clarify, is that the configuration protocol-based configuration, or
the configuration is the RTCP bandwidth fraction and that sort of thing?
Yeah, so I think I kind of agree with Magnus's point that think of you're just a dumb endpoint that knows nothing about congestion control, but you want to participate well with anything that is doing sender-side congestion control. I think you want to be able to have already enough smarts without looking at any RMCAT work to be able to send the right feedback at the right times without having a congestion control implementation inside of yourself as a receiver. So I think that'd be a good goal. The document could clarify that.
Yeah, I fully agree. And I think the only configuration you need to do that is existing RTCP configuration. The bandwidth fraction, the AVPF parameters, that sort of thing.
Should this document say, must actually implement RS and RR bandwidth? I think a lot of people possibly ignore it.
Maybe, I don't know. I mean, I think they're separate. I think the format is a separable issue to how you configure it.
Yeah.
The thing.
Right. Yeah.
And I'm not sure the format wants to say you have to configure it this way, although we could probably say these are appropriate ways you could configure the bandwidth fraction for it.
So
Magnus, tend not to tie documents that closely.
Okay, Magnus, I think I'm fine with not tying them closely. I think this document, however, do need to specify when to send the feedback message based on packet arrival, if it's received packet or not, etc., or in cases when the packet starts to go towards overflow.
I really don't think this document should do that.
But I mean, if you received 0 packets, are you sending a feedback packet? Yeah.
I mean,
something needs to say this. Right?
Yeah.
Yes, but I don't think it's this document.
But
what document is it?
It would be. So I mean, this you just say you configure. Yes, we will send feedback, and you send feedback. and you just put it in all the packets at the
Yes,
appropriate
but I
rate.
mean, the feedback here is that the feedback is about received packets. If you receive no packets, or you're sending a feedback message to indicate that you didn't receive a packet, and then you need to have discussion at least that's happening. And that's, I think, go to another part, which I was a little bit thinking about what happens when you have losses of these feedback messages. And if you have any overlap or anything like that, that's a separate question. But it's this kind of issues becomes evident if you really think about it from a DOM receiver point. Is that I think you need to specify at least what are the criteria for sending this if it's configured.
Sure. Okay.
Jahid, I think I kind of agree with, like, we need to write all this thing. I mean, the CC interaction draft perhaps a better place to describe in these details, but maybe we need to write something about, like, okay, go and look at that if you would like to have like implementation guidelines. And I was not really convinced like this document need to have implementation guidelines. This is just a format draft to me, but anyway, maybe it makes sense.
The draft doesn't need congestion control implementation guidelines. I mean, I think I agree that it needs something that says, if you get 100% packet loss or something, send it. What to do when the sender stops sending you packets, that sort of thing. Yeah.
Mosin, I think maybe a practical example would help flesh out the issue. Suppose that we say it's only configured through RTCP fractions, but those are maximums. What if somebody says 100%? I will allow you to do whatever you want. The draft, if it's expected to be configured only through that, still leaves a lot of leeway to say, should you always fully saturate your RTCP bandwidth, or do you choose to be very conservative and only use what you think is reasonable as a receiver? So I think that leeway sort of depends on what the sender's congestion control algorithm expects. So I think that's the mismatch, that just using the RTCP bandwidth fractions to configure this misses that. Okay, if somebody says 15% RTCP bandwidth, does that mean you should always saturate your RTCP bandwidth at 15% and send as fast as possible?
That is what the RTCP bandwidth fractions means.
It's a maximum. It doesn't mean you must send RTCP
it's
this
not
fast.
a maximum.
Well, no.
It's an allocation.
Not if you CRRN.
Yeah.
AVPF under rules will usually not saturate the bandwidth.
But
It can.
But AVPF has configuration parameters, and you would specify those. So
Yes, but even if you specify no, there are cases where you're not actually saturating the bandwidth.
Right, but the goal is not to change anything. It's to say use the existing signaling and do it in exactly the same way you normally would.
Mogan, but I think the practical thing is the implementers should have pretty clear guidance of what to do. And I think it's if I was going to implement this as a receiver, I don't think I'd have to have extreme knowledge of all the RTCP specs and then still have enough wiggle room to maybe throw up some senders algorithms and work well with some other senders algorithms. So I think a little bit of practical guidance for an implementer of a receiver stack would help. Always send within at least this time frame, or reference this document to show that there's a deterministic algorithm for telling you how many packets do you have to accumulate before you send out a feedback packet.
So I don't think that makes sense. I really think what this is doing is saying configure the RTCP bandwidth fraction which will tell you how you would normally send your feedback. And when you send feedback, report on all the packets you got during that interval.
So,
yeah. And I think it's that straightforward.
Jahid, I kind of agree with Colin here. I mean, you don't want to set, because as you said, like you mentioned, Mo, like the sender algorithms, it could be different demanding. So I don't think like this document has to do with that. What it can definitely do is like, okay, pointing to your saturation kind of thing, like, well, you have other feedbacks to also send, like you have feed and package loss rate, PLR, and all this to send. So when you're saturating your RTCP bandwidth, you need to think about those things. Like, shall we be saturating all the RTCP bandwidth I allocated for this one only for congestion control? Then I need to send feed and then need to wait, or what? So that kind of, I think, like we can say something in the document, like you need to, before you saturate the RTCP allocation with CC feedback, if you're using some other feedback message, you need to also calculate that one. Just a hint, like people don't make mistakes. So this, I think I agree, but I don't agree like you really need to specify within this amount you need to send feedback on, because that's condition control candidate specific, and that should not go here.
I mean, this might be something for the RMCAT draft that talks about how you configure RTCP fractions. I really don't think it's something for this draft.
So, Magnus Westland, I agree that we can't specify it in packets, etc. And we need to kind of follow the RTCP timing rules, what they give, etc. My comment was really about there are some cases is like, are you sending or not sending it even if you didn't receive packets? I think that's one thing.
And
Which,
that one I think we should definitely clarify.
Yeah.
Yes, absolutely.
and thinking about this, are there similar very basic things like that has to do with, and maybe think through what happens if, what will happen if you actually lose this feedback message, etc. How does it look for the one that receives the reports when they get sparsed due to packet loss?
Yes, but I really think we should not be trying to re-specify timing rules here.
No.
Yeah.
So speaking as an individual here, I feel like, sorry, exciting to the cables here. I feel like, yes. So CC, the RMCAT draft and the various conditional algorithms are what somebody who's implementing, who a media sender, congestion control implementer should need. This draft should be everything a media receiver and feedback sender should need, plus the RGP specs themselves, obviously. But I mean, they should not. I mean, somebody who's just providing feedback and not implementing congestion control shouldn't need to read any of the RMCAT draft.
Sure. Yeah, sure. I mean, they should be expected to do the thing that's configure the timing and the IETF parameters and so on as specified elsewhere.
These are the configuration parameters you'll receive and act on them as specified in these other documents.
Yes.
So they won't need any guidance on how to set those configuration parameters, but they need to know how to act on them.
Yeah, I mean, this should probably say you will likely get these types of configuration parameters for your bandwidth fraction,
and possibly even these are things which you may have not bothered to implement in the past, but you really need to do that now.
Yes. Yeah, I mean, what I think, what we've never done in this group is said you must do this sort of signaling. We've said this is an example of the type of signaling which will work for it, but there may be other ways of doing it.
Right. The other thing that's a little bit unclear to me, for instance, is so are you expected to send feedback on every early feedback option? Because sending early feedback is optional in AVPF. If you feel like this is an appropriate time to send it, you send it. If not, you don't. So if this is now a case where you're expected to send it always, that's something that needs to be said here. And I think, especially because I'm fairly certain, if I remember the details of AVPF right, that precludes you sending immediate ever.
Yeah.
Which is an interesting implication if you need to sometimes send immediate. So
I think you end up alternating.
I don't remember.
Yeah, I'd have to look it up again.
Exactly.
Yes.
We need to figure out things like that. Are you expected to use every valid early feedback slot with, if they receive the packet in the last interval? Things like that is an important thing to discuss here.
Yeah, okay, sure.
Hi to all, John. Just a reminder, this document will be used by people who do not use SDP signaling. So defining SDP signaling is fine. Requiring SDP signaling is not.
I think that was my point. Yes.
Yeah, no, I meant more in the terms of, regardless of how you're doing your signaling, pay attention to, if somebody's configuring your RTCP fractions, pay attention to that. Don't just hard code it somewhere.
I know you know.
Okay.
Ronnie, I was not following much the RMCAT work, but I'm wondering if the receiver doesn't support this message, but it sends ECN, for example, the ECN marking. Does our RMCAT address this case where, when we negotiate and you don't support that, you support the other ones? So you can get the information. What I mean, you can get the information from other RTCP feedback if they're supported.
I mean, I think that depends on the RMCAT candidate congestion controller, and some of them might, some might not.
But you don't address this in any of the RMCAT that you can work around even if the receiver doesn't support.
As I say, I think that depends on the implementation and the RMCAT candidates, and some of them might support alternative types of feedback, some might not.
Jahed here.
I mean, obviously, if the congestion control doesn't do ECN, obviously it's not going to work with that feedback, right? So we can't give general guidance.
So the idea here is like this CC feedback here. We agreed in RMCAT that this is necessary information to do the condition control. One of the signal was like ECN, but it's not only the ECN. So some of the algorithms like Scream or NADA, they can react on ECN, but how efficient would be that only to react to ECN, and that has not been discussed. It was like if you read the draft. In the draft and the analysis part, we did like these are the information is like packet identifier, then offset, delay things, and ECN. So ECN is part of it. Yes, we discussed this in RMCAT, and some of the algorithm actually has implemented, like Scream has implementation of ECN reaction, and I think NADA also has that. But whether only ECN signaling will do the trick, that is not part of the evaluation, at least in RMCAT evaluation.
So I think an RMCAT candidate, I think the goal is that the candidate should be able to work using this. If the candidate is also written in a way that it can fall back to using some other type of feedback, if that's all that's provided, I think that would be a good thing. But it's not something
I think it is like that. It is like that. If you get an additional signaling you want to use, fine. But yeah, I mean, but then RMCAT, I think RMCAT proponent cannot really. We have not evaluated just only for like how much efficient we are to only take ECN as a signaling. That we haven't evaluated. We don't have result on RMCAT. Just for your information.
Hello, John. Ronny, I would be a little more brutal. RMCAT is about delay-based congestion control. If you don't have information about delay, you can't do delay-based congestion control. You might have fallbacks, but in order to have delay-based congestion control, you need information about delay. You need this thing. Anything else is fallbacks.
Yes. Right. Yeah. Absolutely.
So, I mean, I think this as an individual again, without setting up. I know there was some. So I don't know if we want to have guidance about this in this draft or not. There was discussion about whether, since you're getting essentially a full, NAC report for all your RTP streams, would it be interesting to, people are saying, well, I want to use this instead of, the NAC feedbacks and whatever, because that ends up being redundant. That's what we want to tell people, you can do it if you want, or no, that's a bad idea, or leave not mentioned at all.
It's probably worth noting that it would be redundant to send NAC feedback, but I suppose if you want to configure it, then why not? If you want to waste capacity, that's your problem, right?
Jahed, again. I mean, we have a section called Design Rationale where we actually talk about tell people already have some of the XR block and some of the signaling that they can do. But yeah, we have not talked about whether this is good enough. I mean, the rationale was there is no way to sell arrival time stamp. There is no signal right now. Yeah, but
I mean, more like to what extent does this overlap? Is if you're sending this, can you then drop off other feedback forms?
I think you should do what's signaled, and if that is stupid, then okay, someone's asked you to do something stupid, but go ahead.
On the one hand, yes. On the other hand, sometimes what would it make sense to signal?
Oh, sure.
Yeah.
I mean, noting that some things are redundant with this, I think makes sense. But if they're
I think we can say that this is redundant.
It's possible that if you look at the details, yes, if this looks like NAC, but actually NAC has some subtle differences in terms of what happens if feedback gets lost, or if it was, with NAC, a receiver could say, yes, I actually want this packet, as opposed to this just says I got it, but if I didn't get it, do I care? That's sort of semantically different. So maybe there should be warnings that no, it's not the same as that.
Yeah, I mean, if there are overlaps or concerns like that, we should obviously note them. But again, if someone wants to signal that you should do something stupid, then you should do what the signaling says.
Yeah, I think I agree with that.
Sorry to start this discussion, but what you're telling us, go read the RMCAT documents and see if they are correct. That's what you're telling us, basically.
One of the things.
I'm not sure that was what I was telling you at all, but
He wouldn't disagree.
but please do read the RMCAT documents and give feedback.
The other thing, I think this is more as a chair, this is something where I would like to see some implementation experience before we finalize this, because there are a lot of these details, and also it's, how does it behave in practice in real networks? I know that some of the RMCAT candidate developers are looking at switching to implementing this in real systems, so hopefully we'll be able to get.
I think sort of with my RMCAT chair hat on, I think we would need to see that it works with at least one of the candidates before we went anywhere with it.
Okay,
And ideally several.
Yeah, so we want to both that it works with the candidates and it works, on its own, and the draft and the document is implementation experience also tells you, if you understand, well, how often, the details of, I don't understand how often I'm supposed to send this, or what I do in this corner case, or whatever. That will
Exactly. Yeah.
All right, so.
Yep.
And that's, and you expect, as RMCAT chair, you would expect that reasonably soon?
For some definition of reasonably.
Okay.
Yes.
By IETF standards of reasonable?
Yeah. I mean, I suspect it's not that big a change to the implementations to switch the packet format to the feedback for at least some of the implementations.
Yeah. Well, I think the main thing is how do you behave if you miss a feedback packet?
But I mean, they have to deal with that anyway, because that can happen whatever the format is.
True, yeah.
So, okay, thank you.
All right, so we're kind of behind schedule, but as I said, we have an hour more than we think we do. So, Mo's next. Yes, you're here. Yeah, Fred Martin is next. But we're running behind. That was a lot longer than 10 minutes, but we're gonna use whatever the session was that was going to be after.
Okay. This might not take the full 20 minutes. So Mosinati, on behalf of Espen and Suhas, and on the RTP header extension for frame markings. Next slide, please. So version 06, quick review of what this work is for. The main motivation is to be able to support RTP switching topologies, where you have a middle box that does not transcode the media. It just switches the media, and often the payloads of that media will be encrypted. So one of the motivations is to be able to save re-encryption costs at the middle box, so you can have better scale and latency. And there's also cases such as PERC, where the middle box will have end-to-end encryption that it cannot read. So it doesn't have the keys for being able to read the payload headers of the packets. So in that case, it'd be impossible to do any kind of media-specific processing. And the goal of this work is to help surface some of the important bits about the media up to RTP headers in order to be able to do intelligent switching. And then a very more forward-looking aspect of this is that you could potentially support arbitrary payload formats, even new ones, even undefined ones, that the middle box, if it has support for this header extension, it could understand these other formats, understand how to switch them intelligently without necessarily having to implement anything specific to that payload format. Next slide, please. And then some of the other benefits is that you can have a better experience, because the video can be switched cleanly at intra-frame boundaries by the middle box, even if it's totally unaware of what's inside the packets. And during packet loss, there's more defined semantics about when the packet loss would affect a certain frame or a certain proportion of the frames. So what could be renderable and what could be not. And then in case of congestion, the middle box can make better decisions about which packets are better to drop towards downstream receivers that have congested links. And it could drop entire layers if codecs are scalable. And then endpoints can also take advantage of this the same way as middle boxes. When there's packet loss, it can understand better what the implications of that packet loss are for frame rendering. Next slide. So this is the header extension. There's two variants of it. You see the length field It can be either L equals 2, which actually means 3 bytes of payload, 3 bytes of header extension, or L equals 0, which is only 1 byte of header extension. The 1 byte version is for non-scalable streams. It only has some flags, start and end of frame flags, independent frame flags, and discardable frame flags. And then the longer extension adds layer IDs, temporal layer IDs, and spatial and quality layer IDs, and picture indices, temporal layer 0 picture indices, so that for scalable codecs, you can do more intelligent layer drops. Next slide, please. So the main change in this version of the draft was motivated by some discussion on the list about implementing this for VP9 SVC applications, but I think it's really generic. It's not really limited to VP9. Any scalable codec would have the same kind of implications, not necessarily the exact bits that were discussed from the VP9 payload draft, but very similar things also exist for 264 and 265. And basically there was a confusion about how to map some of the VP9 bits, the P and the U bits, to the frame marking definitions of the I and the B bits. So we made some changes to clarify how this mapping can be done. In section 3.1 and 2, the definition of the extensions for the scalable and non-scalable streams, we show how to encode the independent bit. Go ahead, Bernard.
Yeah, so I just had a question for, I think, Jonathan, that there was an issue when we had like more than 2 spatial layers that the P and the U bit didn't map. It wasn't because it wasn't neither the B nor the I seemed to really be sufficient to determine what P and U would be.
Well, let me go through how we
Okay.
changed the definition of the I, and then we'll see if that works for the P. Is that okay?
Yeah.
All right. So the I bit was basically changed in definition to only signal temporal independence. And so in that case, it's basically the inverse of the VP9 P bit. VP9 P bit is predicted frame, which means the opposite of independent frame. It means that this frame depends on the P bit means this frame depends on prior bits. It's predicted from prior frames. And in the frame marking header extension, the I bit means this is in an independent frame or like an intra frame. It does not depend on prior frames. And so they're inverses, but now with only specifying the temporal aspect in this version of frame marking, then you can have dependence on lower spatial layers and still mark the I bit if you're not doing temporal prediction to previous frames. And then there was for the U bit, there was discussion about when you could do up switching to higher temporal layers, and I think the rough consensus on that was that the scalability structures that are recommended for this draft would be restricted to simpler structures that can only support temporally nested hierarchies. So we changed that in 3.4.2. It's recommended for temporally nested hierarchies, and it's not recommended for other scalability structures. So basically, in that case, the U bit is always set. The VP9 U bit would always be 1 for all the frames because you could always up switch to a higher temporal layer at any time. Next slide, please. Give a little more detail about the I bit here. So this is what I think Bernard was asking about. What does the I bit mean? So we changed it to mean only temporal independence. For non-scalable streams, it's very straightforward. It's basically still I frame or P frame kind of semantics. We just modified it to say it's only for temporally prior frames. Next slide. This is the more important case. For scalable streams, the I bit is again still just temporal independence. So if you set this bit, then you can set it to 1, even if there are spatial or quality enhancement layers that this frame does depend on. So previously, you couldn't set this bit unless this was truly independent, that it had no other dependencies. But now you can set it even if it has dependencies on lower spatial or quality layers. So that's the main change that aligns it with the VP9 P bit.
Is it expected that this would be, I mean, so I guess my question is this actually, so in the context of like LRR, would you expect that this would be required to be the same across all spatial layers of a picture, or could it be set in separately for different spatial layers? Because that depends whether it's satisfies an FIR, whether it satisfies an LRR.
I don't see a need to restrict it to have all layers have the same bit value. I could easily see a case where you have maybe the higher layers are not intra because they're very expensive to code intra, but the base layer is intra.
Yeah. So which is to say it signals in the LRR context, it would signal that this is a layer refresh, not actually a full intro, which means figuring out if what you got as a full entry means you have to look at every layer and figure out if they all had on.
Yeah, I think that's right.
Okay. Probably worth pointing that out.
Okay. Next slide. Okay, for scalability structures, again, this is related to the VP9U bit, which allows up switching to a higher temporal layer. We clarified that basically align it with the LRR draft in its nomenclature. We use the same definition for temporal nesting that LRR uses. So here it's only recommended for the case of temporally nested scalability structures, and it's not recommended for any other cases of scalability structures. So that means that the VP9U bit is basically always inferred to be 1. So now, Bernard, do you see any remaining issues? And I don't know if Sergio was was one of the ones
So
implementing this.
yeah, if I'm trying to remember the case you had in your draft, Jonathan, it was a case where we needed to upswitch in scalability, and basically there had been a temporal dependence, and then finally there isn't one, and you needed a way to signal that this is the place you could upswitch. Particularly, I think if you have like more than 2 spatial layers. And I think what we're saying here is that the I bit would, at the upswitching point, the I bit would become 1.
Right.
And that would be true for spatial, for that spatial case.
Right. And for temporal, what we're saying is if you're using frame marking at all, it means it's a valid temporal switching case. Because
right, but I think that case was largely okay. So I guess the only thing I would ask, Jonathan, is, are any of the structures you described, all the structures cases you described in your document will work with this, right? They're all temporally nested?
Oh, I mean, I showed an example of non-temporally nested in my document, but that doesn't mean I'd ever want to use such a thing.
Okay.
Yeah, and I think Sergio also replied that he was wary of requiring temporal nesting because he wouldn't want to have to change VP9 implementation. And I think all of the implementations that I've seen do only implement temporal nesting. So I have not seen a VP9 encoder yet, certainly not libVPX, that will do a non-temporally nested scalability structure. So if someone has one,
yeah,
I'd like to see it.
Yeah, I would certainly hope, for example, the AV1 code is focused on temporal nesting. Let me put it that way. Doesn't just generate something else by default. Yeah.
So I think we're okay. I think there's no practical restriction for usable streams.
Mm-hmm.
At least for anything you do for interactive.
Yeah. All right, next slide. So this is not an update in the draft. This is an explicit non-update. So there was a discussion about whether the discardable bit should be expanded to have different levels of discard priority. That was not put into the draft, so there's no changes for it. I mean, Ronnie has a more granular definition for priority markings of non-scalable streams in his draft. That's it. Next slide. So I think we're ready for work group last call. We don't know of anything that's open. A little more review would be good, but it's good to see people actually implementing it and giving feedback about the implementation.
Last call. Probably. I mean, I think we want to look at Ronnie's proposal and decide if the working group wants to add that or not. But other than that, but Bernard, I see you're still in the queue. Do you want to say something?
Yeah, I think the all the issues I recall are now resolved. So.
All right. Okay, I think, yeah, we'll probably, unless something comes up, we'll probably do a working group last call on this shortly after this meeting.
Okay, so just on the comment on the question about, I mean, there's no reason to delay for that. I mean, just go ahead. I mean, that's why the reason I wrote a separate document is that what we discussed in Prague, and we'll have it. You can continue with the frame marking, and then we can decide afterwards what we want to do with that if we want to do that. So no dependencies at all. So this is why it's written as an update to the other one whenever. Okay. So. What we propose here is to do some priority flags for frame marking for the non-scalable stream. We did some tests by co-author, does all the tests on that, and he found out that there are good results, that he can have more options if those are available. So the cases so we suggest to add priority values for the non-scalable streams, droppable frames. Like it was discussed in Prague, and that's why we submitted the draft. So it will allow the middle box to discard part of or all the discardable frame is marked by the encoder. It's provide more option for changing the bitrate on congestion. So if for example, if I have contiguous number of frames that are droppable, I can mark the ones that are better to be dropped off. So if I don't need to drop all of them, then what is the preference, which one to drop? It provides more flexibility in adapting different bit rates accordingly. Basically, you can try to do some heuristic without that, but it's if they are to reorder the packets, so that provides better granularity for that. So that's the first use case. The other one is to allow differentiation between reference and non-reference B frame. So if I drop first the non-reference B frame, then I can drop the referenced one afterwards. Again, it's more granularity in what I'm dropping. And the last one is we can also have P frames can also be dropped because the closer they are to the next to the end of the GOP, they are less important than the one in the beginning because soon you'll have a full frame that you can resynchronize. So in the worst case, I mean, if you want to go this way, you can have this with the priority that's the last to drop. Okay, so these are the cases that we analyze and try to bring forward. Next slide. So what we're suggesting is to add 2 bits from the 4 must be 0 bits. When 0, 0 is the highest drop priority, and 1, 1 is the lowest drop priority, which means highest lowest priority is the ones that you can drop, and that means that if you don't support this extension, then that's what will happen basically.
So, as an individual again, how is drop priority different than a temporal layer? Aren't they the same thing, just with different?
Okay, so but we're talking about non-scalable ones, and the reason for that, I mean, it's mostly we figure out, and the use case that we had was mostly when you're coming to the to Wi-Fi, where you have, I mean, the situation there is that you have to drop because at the home when you're trying to watch a lot of videos at the same time, you have to drop, and we see, I mean, that's may not be scalable videos. Okay, so in this case, that's where the use case that we had on that.
I guess my point is, if you say that, okay, I've got a bit stream and I can safely drop this subset of it and it's still a valid bit stream, that is scalable video. You're just not encoding it, thinking about it.
Yeah, it's not encoded as a scalable one.
Yeah,
it's a non-scalable.
It happens to be scalable.
Yeah, okay, and not at least for the P bit, it's not really scalable. I mean, the case for the P bit, but also it's also for the case of, I think the only case you can say it's scalable is the reference and non-reference B frame. Also, if you have a contiguous B frames and you want to mark which one you can drop, then again, it's not really scalability. It's mostly, it can be any other decision that you can make on that.
So this is intended much more for the stream content model than the conferencing model that you're using?
Yes, it's the content one.
Yeah, Mozanetti, I think when we discussed this before, frame marking's goal was to make sure that something is decodable. So if your middle box, you know that you're forwarding a decodable stream without error, whereas this is more useful for even something which may not be decodable artifact free. Even you're trying to minimize the artifact, you could use this to minimize the amount of artifact, but you don't guarantee that there's no artifacts. You're allowing some level of artifact, but you're trying to minimize them by having more granular priorities. Whereas the other frame marking draft is talking about artifact-free video. What can you do to guarantee that you have a fully decodable, fully renderable, artifact-free experience to all the receivers?
And that's when I read your presentation now, it's a bit different than what I understood what you want, because the presentation was talking, and you're right, the presentation that you presented was discussing mostly the case for how to, which one to pass, not what to discard. Okay, but my understanding of the document, and from the document, it's not only because you have also the item says, it's also what you can discard. And discarding doesn't necessarily mean that it will be without any effects.
No, just Mo, to clarify, the document, the other frame marking draft does say the discardable, the definition of the discardable bit is it is discardable and still allows a fully decodable media experience. That's the definition of the discard bit. You can only set it if something is truly discardable and not impacting decoding of other frames. So you cannot set that for something that would degrade the, cause artifacts in the stream. So maybe let me know if there's something in there that suggests otherwise, because we need to clean that up. The intent is that you can only set that bit if you know that this will not impact the rest of the stream.
Of course there is, because for the non-scalable case, I mean, if you have discardable bits, I mean, it's always things that will disrupt somehow the...
No. So even in a non-scalable stream, you can just, every now and then just have something as non-reference, right? You have a flat temporal hierarchy, no special scalability, just every now and then.
If you drop a frame in a non-scalable stream, then you affect the decodability.
No, I'm saying, I'm saying at the encoding, I'm saying that the encoding of the frame, you actually made this a discardable frame. At the encoder, you coded it as a non-reference frame. So it's not the middle box dropping it and discarding it. It's the encoder choosing to encode a discardable frame.
Okay, so we are adding more dimension that says, okay, you can drop more than that if you must, if you have a big congestion, congestion inside, and that's why I said it's typical in Wi-Fi at the home network, basically, that you run into this case. Okay, and as I said, I mean, you could go to the next slide. I mean, the only thing is that I don't mind it if we can finish first the document and then go and work on that. But we really would like to have this option as an update to the.
Are there actually, is there a place where this will be used?
Yes, I mean that's why we are doing it, because we are trying to use it inside in the solution for our Wi-Fi residential gateways and stuff like that, where we have a problem with going into and that's mostly for of course for streaming video, not for conversation.
Mozanetti, remind me how this is negotiated. It's a different parameter than the regular frame marking. How's it negotiated? Is it a different header extension than the regular frame marking?
No, it's the same. It's just adding to. It's using 2 of the 4 bits, but if you don't support it, there will be 0, which is the ones that are really you can drop.
Is it parameters on the current header extension? So how do you negotiate an SDP? Is parameters?
It's this current. I mean, I don't add any negotiation. It's like I don't need to, because if it's supported, then I'll see priorities. If I don't see priority, it will be 0. Go back.
I think you would want to still want to signal it, because otherwise let's say you support this mechanism, but you don't know whether the sender.
Okay, so okay.
If they
suddenly,
yeah,
the thing is that
if the sender supports it, you don't want to drop anything that has 0, 0. If the sender doesn't support it, you will have to drop something that has 0, 0.
No,
Yeah.
I want no. If it's 0, 0 is the one that you dropped at the highest
Oh,
priority.
okay.
Okay, so that's why I said it's the same thing as before. I don't change it. That's what I meant by that. So I've said there's no problem with support, if supported or not, because if you don't support it, you ignore these bits. Okay, if you support it if you support it and you don't see them, then you'll see 0, 0, only 0, 0s, and that's what means it's the highest priority for dropping. That's why I said there's no problem with backward interoperability with the current definition.
Except that somebody that didn't implement this may think that it's a violation of the frameworking must be 0, and I wouldn't want to drop the.
No, I think frameworking should say 0 on send, ignore on receive. If it doesn't say that, it should. That's generally the way.
Yeah,
That's
let me double check.
it should be ignored if
Yeah, let me double check that it actually does say that. Okay, so they'd be inferring by that this being non-zero that you support it.
Yeah.
I mean, I would still say,
I don't mind negotiations, but I see no problem with interoperability.
yeah, no, yes, aesthetically, I would still prefer to put a parameter, because headers are just put parameters on them. So put a parameter on saying it's worth it for this.
Okay.
So,
No
Stefan Wenger, first, I don't think you need a parameter, but independently of that, it's an old idea. This is stuff that actually, when we did the H.264 null reference IDC thing, those 2 bits in the null unit header for H.264, which was also mirrored in the payload format, those were initially in the initial proposals were meant as encoder selectable and not specifically nailed to the null unit type as it was later done in that committee. The reason why they did that was because people argued, whether that's a good argument or a bad argument, I don't know, but people argued that it is very hard to put a concrete definition on those relative priorities. So, for example, an encoder from one manufacturer may decide to mark everything as high priority or as essential for decoding, which would lead to a PSNR decrease of 0.01 dB or greater. Whereas another encoder manufacturer may decide, well, we want to be able to discard 50% of the packets at least. So we are assigning those values such that at least half of the packets have values like, in the 2 and 3 range of those 2 bits. So that was, and interoperability in this scenario would be a pain in the neck unless you come up with a definition which was, even doing it for H.264 was deemed impossible. So have you thought about that?
Yes, and I think it's not that relevant, because from the stream itself, it's just that if I want to be able to decide from the stream which one to drop, which one to drop and which not to drop, then I go accordingly. Okay, I don't care how it's related to other streams. In this stream, these are the first I should drop, because if I want, and mostly because if I can provide, and mostly because I can provide more options to not to drop, to have all of them to be dropped, and to make decision if I want to drop just part, because I need to reduce the bandwidth less than what is the number of frames that need to be dropped. So
the algorithm is essentially you decide, or your congestion control decides, no, not your congestion control, this is a receiver thing, so it's not congestion control, it's something else. It's like you don't have the cycles to decode or something like that.
It's not a receiver, it's basically the middle box that passes it into
So the middle box has decided at this point I need to drop something. Then it looks through its queue, which is hopefully mercifully short, otherwise we have too much delay, right?
Mm-hmm.
And if it finds something that's droppable, then it picks one of those with the lowest of these indices. That's the idea, right?
Yeah.
Yeah. Okay.
Okay.
Bernard, are you still in queue or are you just sitting there?
I'm just sitting there.
Okay.
Hi, Bernard. For the next one.
Yeah. All right. So what do people think? Is this something people would be interested in adopting here? Anybody feel interested?
Okay, so
I'm not particularly interested and not particularly uninterested. The cost of this is taking 2 bits away. There's no harm in this proposal except that it takes 2 bits or 4 reserved bits away. Is there anything on the horizon where we need 2 other bits?
No, and these bits are only free in the case you're not doing temporal scalability.
I understand. Yeah, but
So,
yeah.
They're because you need the byte, that's all.
yeah.
Right.
I think the primary, honestly, I think the primary cost of this is it's something the working group is doing and we have to pay attention to. So,
easy enough to do.
Mozanetti, I resisted doing this in the context of frameworking because I thought it would be difficult to actually specify what senders should populate this with, and so I didn't want to hold up frameworking for a potentially open-ended discussion about how to actually signal these bits properly. In the absence of specifying how to signal them, I feel it's a little impotent. So if the document doesn't say anything about what you actually do with these bits, then it's a little,
So just to clarify, you want to get more information about how this how those bits are marked in which codec that we tested in?
Right. Yeah, because like, for example, the frameworking bits are very deterministic. So it's clear how a sender must send them. There's no ambiguity. So we don't need a lot of rules and discussion about how they should be marked. This is something where it's more subjective, that there are, different ways that, senders may choose to mark them. So you need to have some guidance about what you should do. And that's what I wanted to avoid in frameworking. And if they didn't have that information in this document, I'm not sure if an implementer could actually make good use of it.
So the information that we had about the B frame and the P frame, it's there. I mean, which one are to mark higher and which one to mark lower priority for B frame and P frames.
well, I mean, I think Stefan's point about one implementer might choose to mark 1% of frames discardable, another implementer might choose to mark 75% of frames discardable, has a big effect on how the middle box behavior ends up dealing with it, right?
Which one it will drop when it need to drop, but it's for the specific stream. I mean, that's all. I mean, it doesn't affect any other streams. It's just for this stream. I mean, how you decide which one to mark and which one discardable. That's what you're saying. You're telling the middle box that these are for you are less important and this one are more important. So you should first drop the one that are less important. That's all.
So Mo, again, so my net feedback was that I don't have any objection to taking it on as a work group item, but I think it would need more work to get clarity about how a sender would actually mark things properly.
I'll go and add some more text on that. And again, I mean, we can start working on it after we finish with frameworking. I don't want to hold frameworking. It was not our intention at all. Okay.
Colin Perkins. So again, I have no objections to this work carrying on, but I do agree with Mo that we need to specify how the marking is done in order for middle boxes to do anything meaningful with it.
Okay.
I mean, and the other concern I always have in this sort of thing.
Sure, but if it's 1% of packets marked, or if it's 75% of packets marked, the middle box treats them very differently. I mean, that's a real point.
And the other concern I always have is I feel like this group has very poor visibility into the streaming community. So I'd like to get sort of a more feeling of who else in the streaming community would find this useful and interesting.
Okay.
All right. Yeah. So I think sounds like at this point, we're going to probably delay taking it on until framework proper is done. But if Ronnie wants to keep updating it, that's great. Okay. All right. And next we have quick multiplexing, I believe. And I'm pretty sure we have the latest version of your slides. Okay. So if you've downloaded the slides, Colin sent us a new version of the slides during the meeting. So.
Because I'm really organized and had these done in plenty of time. Okay.
Because you kept improving.
I kept improving them, that's right. All right, so I'm still Colin Perkins. I want to talk about Quick and how we multiplex Quick. Are we finishing at 11? Do we have full time?
I think we're going to run over into the canceled 11 to 12 session.
Okay, good. All right, so Quick, if you haven't been paying attention, is a new transport protocol. It layers above UDP and is initially intended to replace TCP in the HTTP TCP stack. So there are browsers and servers out there which are running HTTP over Quick over UDP. And Quick may or may not be a good thing. Lots of people have opinions on that, but it is certainly something which is happening and becoming popular, should we say. The initial focus of Quick is on client-server HTTP, right? It's defined as a client-server protocol. In the long run, it should become a general-purpose protocol, a general-purpose transport protocol, and will be useful for the same sort of things which TCP is useful for, but hopefully offering some improved performance in a bunch of cases. It would, there are two things which I think it would be useful to do with Quick, right? It would be useful to run Quick in a peer-to-peer manner in the long term. So it's not just for interacting with web servers, and we can use it for other things that need peer-to-peer transport. And I think it would also be useful to be able to coexist with Quick and WebRTC traffic on the same UDP ports. So, thinking through those both a little more. I mean, the first goal, right? I mean, initially, Quick is being specified as a client-server protocol, HTTP over Quick. If it's going to be general purpose, it's going to end up being used in a peer-to-peer way. If it's being used in a peer-to-peer way, it will need to work through NATs, which means that we need a NAT traversal scheme. The way we do NAT traversal in the IETF is using ICE, which means you have some sort of signaling channel and you have stun running on the same port as the data to open the NAT bindings and keep the bindings alive and all this sort of thing. Now, signaling we can do later, right? We're clearly going to need to define some signaling, but that's not something we need to worry about right now. But in order to do this, we need to be able to run stun on the same port as Quick. Right? And they must run on the same UDP port, otherwise stun doesn't work. It has to go on the same port as the data. In order to do that, we must be able to demultiplex stun packets and Quick packets running on the same port. Or we must reinvent stun as part of Quick, and stun has been painful enough as it is, and redoing all that work in the context of Quick is not my idea of fun. Maybe other people like the job security. But I think we want to I think we need to find a way of multiplexing stun and Quick packets. Next slide. In addition, WebRTC is starting to get widely deployed. It's likely that we will have web servers running HTTP over Quick rather than HTTP over TCP, and we might want to run WebRTC from those servers to the browser, so you can make calls to a server co-located, to a WebRTC endpoint co-located with the server. And yes, in principle, we could run that media over Quick, put RTP inside Quick and so on. In principle, we could do the key exchange using Quick and then just use that to key the SRTP because there's a DTLS handshake runs inside Quick. But in the short term, that's a lot of specification work. So if we want that use case, we'd want to be able to demultiplex the DTLS and the SRTP packets from the Quick packets on the same port. In addition, there are people talking about using Quick as a replacement for the WebRTC data channel in peer-to-peer use cases, which would use the stun stuff, and also we'd need to do all the rest of the demultiplexing and demultiplex with the media and so on. And in both of those cases, it would be useful to be able to demultiplex Quick packets and the packets being sent by WebRTC, so stun and turn and DTLS and SRTP and so on. Next slide, please. Okay. So of those two, I mean, to my mind, I think the essential one is that we be able to demultiplex stun and Quick so we can run Quick in a peer-to-peer way. While we're doing that, it would seem useful to be able to, if we can, to be able to also support demuxing all the other protocols we use for WebRTC. So how does WebRTC currently do the demarcs? Well, currently, if you have a WebRTC endpoint, when the packet arrives, you look at the first byte of the packet. Right? And if the first byte is in the range 0 to 3, you forward it to your stun implementation. If it's 16 to 19 and you're running ZRTP, you run it to your ZRTP implementation. If it's 20 to 63, it goes to your DTLS. 64 to 79, it's turn. 128 to 191, it's RTP or RTCP. You forward it to the appropriate bit of your stack based on the first byte of the packet. And yes, this is a clutch. It's a horrible clutch. It happens to work by luck. We've kind of semi-formalized it in RFC 7983, but clearly it's a clutch. There's not really, if I remember right, a good extensibility strategy for this in 7983. I don't believe there's an IANA registration policy for how we add new things in here. It's a mess which happens to work because we got lucky. If I am remembering right, and Magnus will probably clarify, a lot of this was done because things happen to work out. I think if you're running a stun server, then you'll see stun and turn packets on that port, but probably not the others. If you're running a WebRTC endpoint, you'll see stun and DTLS and RTP, but probably not the others, and so on. And so we don't necessarily need all of these combinations for every endpoint, but things happen to work out that way, and it's all been defined such that and documented, so it's clear how it all works. Okay, next slide. So how does Quick fit with all this? Well, there are two types of packets in Quick: long header packets and short header packets. A quick long header packet is used for the initial negotiation, the sort of initial handshake, version negotiation, that sort of thing. And then it switches to short header packets once the connection's going. Long header packets, the first bit of the packet is set to 1. That's then followed by a 7-bit type field, a connection ID, packet numbers, versions, and the payload, and so on. Currently, packet types 1 through 6 are defined, right? And there's then a connection ID, etc. But that gives you a set of values for the first byte of the packet, which range between 129 and 134 for long header packets. And that conflicts with the range RTP and RTCP are using, if you look at the first byte of an RTP or RTCP packet. Quick short header packets. The first bit is 0. There's then a bit to indicate whether there's a connection ID present, a bit called key phase, which is to do with the keying and the security stuff, and I don't quite understand, and a packet type field. And currently packet types 1 through 3 are defined. It's followed by an optional connection ID, a packet number, and the payload. But again, we only really care about the first byte. Given those values, when you look at whether the connection ID is there or not, if the key phase is there or not, this gives short header packets where the initial byte fits in the range of either 1 through 3, 33 through 35, 65 through 67, or 97 through 99. And those conflict with stun and DTLS and turn, if you're trying to multiplex them all. So, as it is, these just do not go together with RTP and stun and turn and all of the other things on this box. Next slide. So, what do we want to do if we want to run these together? How can we address this problem? Well, in the Quick working group on Tuesday, Martin Thompson talked about this. He walked through these 4 options. Option 1, just rely on the crypto. All of these packets are authenticated in some way. So you can just run, you can check the signature of all of the packets, you can try and authenticate them, and you do whichever works. And it's horrible. It's probably not the most efficient way of doing this, but it would work as a fallback. And no one likes it, and I can see Mo shaking his head, but it would work. Option 2.
I guess what that does mean is if any option which works with high probability but not 100%.
Yes. Yeah, I think that's the important thing. If we have something which is probabilistic, you can fall back to checking the signatures in the worst case. And we don't want to do it, but we could. Yeah. Option 2 was rearrange the quick packet formats. Make it so that all of the quick packets start with the top 2 bits set to 1, and that avoids the collisions entirely, puts them into a space that's not used by anything else. But the quick folks don't like that. They want to be able to use all of those bits potentially, but it's a possibility. Yeah. Option 3 was to add a single octet shim to the start of quick packets when used peer-to-peer. You put a single byte at the front, which with a non-conflicting value, and say this is, this byte will always be present when quick is running peer-to-peer, which in practice would probably turn into this byte is always present if you're using quick, otherwise you ossify, and it stops working in some cases. But okay, so we add 1 extra byte to demultiplex. And option 4 was just try and avoid the conflicts. We don't really care about demultiplexing with turn, because you're only going to see that if you're talking to a stun server, a stun or a turn server anyway, and you're not going to be running quick to a turn server because why would you? We could replace the DTLS with the quick keying. We do the security handshaking quick and then just export the keys, so we don't need to run DTLS. We only use long packets during the handshake, so the fact that they conflict with RTP doesn't matter, because by the time you've done the handshake, you can do that and then you can switch to RTP, and you never send both at the same time. And yeah, okay, it mostly fits if you squint a bit and pay attention to the sequencing. And clearly none of these are ideal, and I don't think anyone was desperately happy with any of these solutions in quick. Next slide. There's also been a bit of an offline discussion since then, and Martin sort of hinted at this in the quick group, and we've been fleshing it out a bit by email, which is that it seems to be possible to do some renumbering of the quick packets and avoid a lot of these collisions. Next slide. So if we take a quick packet and we look at the long header packets, and currently the packet types which are defined range from 1 through 6. And packet type 1 is the version negotiation, and the rest are various other features in the thing. And packet type 1 is special. That's a sort of mandated, everything must understand this, and the rest is specific to particular quick versions. So the suggestion here is that we renumber these packet types. So version negotiation changes from being packet type 1 to packet type 7F, and all the rest just drop down following that. So we number from the top down rather than going bottom up. And that doesn't do anything to quick, right? It's a trivial renumbering of the packet types. It doesn't change any of the semantics, doesn't change anything else than that. But it changes where they fit into that space in the first octet. Similarly, for the connection ID field in the short packets, rather than having a 1 to indicate connection ID present, we can flip it around. So 0 means the connection ID is present and 1 means it's absent, which is perhaps the opposite of what you'd expect, but there's no reason why we couldn't define it that way. And that flips those into packet ranges that also don't conflict. And again, it's a trivial change to quick. It doesn't change any of the semantics. It's just a slightly different encoding of the bits. So the suggestion is we do that. We give some guidance about greasing and demuxing and so on, which I'll talk a little bit about in a second. But that should avoid a lot of these conflicts. Next slide. So if we do this, the quick long header packets then fit in the range starting at byte values 255 down to 250 for the currently specified quick packet types. So they avoid conflicts with everything else that we might want to multiplex. Quick short header packets, depending exactly which bits are set, fit somewhere in the range of 64 to 127, mostly only a small portion of that range. That conflicts with turn, but it seems to be that this doesn't seem too problematic. Magnus.
Magnus, so you have an assumption that you will not need the connection ID for peer-to-peer.
Yes, yes.
Okay. You didn't state that, but I think it's a very important.
I didn't state it because I don't think it actually matters because it doesn't affect the range. Yeah, I picked the full range here. But.
Yeah, well, I mean, if you actually need the connection ID, you would fold it into the lower 64 bits again
okay.
for the short packet.
Right.
So
yes, sure. So you're right. I missed that. We're assuming we don't need the connection ID here.
Niels Omeyer. I think there's actually no collision with the turn channel, because in case you run a turn channel, you know that everything is going to come through the channel first. You have to give it to your turn client first, and it will unpack it, and then you will give it to, then you demux it further, basically.
Yes, I mean, the conflict would be if you wanted to run, for example, a web server running quick on the same port as the turn server. And
Okay,
I don't
but
see
not
why
from a
anyone-
client perspective. Yeah.
Yeah, and I don't see why anyone would want to do that anyway. But yeah, not from the client perspective. So assuming that we don't use channels for the quick short header packets, and I don't think we need to, no, connection IDs for the quick short header packets in the peer-to-peer case. And I got the impression that we didn't need to, and the quick people didn't think they needed to. Assuming we don't worry too much about turn, then we seem to be okay. Except that the quick people might want to use more of this space in the future, so we might need to give some guidance about what happens if that's the case. And the quick people might just decide they want to expand the range of packet types. They might want to redefine the quick header in some future version of quick to use more packet types, or they might just want to grease the space and send other values of the type field just to make sure it's still possible to send them.
Mosinati, so it looks to me like we're basically defining quick as RTP version 3 in this format.
So this is where it
and that precludes AVT from defining RVT for V3, right?
So this is where it gets kind of interesting. I mean, one way of looking at this is that we're updating RFC 7983 to say, okay, quick is fitting in these values. And those are the values quick will use and it'll demultiplex. And okay, that I suspect probably works reasonably well from our point of view, but I think the quick people would dislike it. I think the other way of looking at it is saying this is some guidance for quick. If you're using quick version 1 and you wish to demultiplex with these other protocols, then when you're doing the greasing or whatever else you're doing, avoid these values. Mm-hmm. And if you're not wanting to demultiplex, just go ahead and do whatever you like. And it's a quick specific thing, and we just give some guidance for the quick people. Or as you say, yeah, we're defining it as RTP version 3, but I think that's not going to go down popularly. Yeah,
and then the other question was, this is trying to multiplex native RTP with quick, but I thought there was also work on a RTP encapsulation using quick.
There is.
So we want to allow both options, and you can multiplex both on the same port.
So from my point of view, the essential thing here is multiplexing stun and quick. Yes. I mean, there is work on RTP in quick. There's also been talk of getting rid of the DTLS because you can do the handshake and just specify how to extract the keys from the quick handshake and use that for keying stuff. Those are long-term things. I mean, specifying RTP over quick is not going to be something that happens, next week. It's going to take a couple of years, I suspect. It's quite a big change. It's quite a different transport. So I think in the short term, it would be useful to be able to demultiplex it. In the long run, I expect RTP will end up running over quick, and it will just be the stun that we care about.
My concern is that if we had so many different competing options, not necessarily conflicting, but suppose you supported them all. Suppose the quick folks actually work on better, NAT traversal than what we do in ART. So then quick has native NAT firewall traversal, native TLS, and native media carriage bindings, maybe a quick RTP encapsulation or something like that. Then we also have this totally parallel universe of of AVT transport of that, and we support both, and you can multiplex both all on the same port. It seems a little. We should be more prescriptive, I think, than allowing all those options.
So we are going to have a parallel universe of RTP over UDP and potentially RTP over quick, whatever we do. And they are going to be demultiplexable, whatever we do. And we can specify how that happens to make it easy, or we can just assume that it might happen by accident. And I don't think this is saying you have to support both. It's saying if you wish to support them, if you wish to be able to demultiplex them, if you arrange if we make this change to quick, then it becomes possible to demultiplex them if you care to do it. Not that you have to do both, and you have to be able to demultiplex them.
I'd allow us, John, strictly speaking, to where to document what. When the quick people are happy, the quick people will have their ranges and stick to them. The important thing about 7983 is that it documents in one place all the different happy people who happen to be non-conflicting at this time. And so I think we need to update 7983, not because of Quick, but because of the next guy who comes along and wants to multiplex something.
Yeah. So, I mean, if you give the next slide, I mean, I do. So the question is whether we update 7983, I think, is a difficult one. I mean, from the point of view of this group, I think it clearly would make sense to be able to say Quick is using these ranges from that first byte, and if you wish to be happy and demultiplex, then that's great. I think the problem is the Quick folks actually want to claim all of that first byte. And they happen to only be using a subset of those values now, but they want the option of using the rest of them, and they want the option of greasing that byte. So I think from a Quick point of view, what we will have is we happen not to conflict with the packet types defined now, but a Quick implementation will probably grease it and use the whole of that, the rest of that byte, but could be instructed not to do so if it wishes to run with these other protocols on the same port, because that particular implementation wishes to coexist. So I suspect the question of whether we update 7983 is actually a much more complicated one than the question of whether we rearrange the bits so the current version of Quick happens to coexist.
Xavier Marjou, coming back to the use cases, mainly especially peer-to-peer with Quick, I understand, I think, the technical use case, which is to have the Quick server behind its own NAT. But could you...
The use case is that is that you can run Quick in peer-to-peer way rather than client-server way.
Yes, but do you have more details about the use case? Is it enterprise or residential? Because
I mean, so the idea is that Quick becomes a general purpose transport. So anything you might want to run peer-to-peer, you could run over Quick.
Okay, understood. Thank you.
And you may or may not choose to do so, but we want to give the option of doing that. And TCP currently doesn't work well in that case, for example, and it might be useful to have a reliable transport that does.
Adam wrote as an individual, I'm glad that you concluded by saying you can run anything you want over Quick, because I think it's kind of key to why this seems like it's doing a whole lot of work that isn't really necessary. I mean, if we can put these protocols on top of Quick, then it seems like the problem's reduced to how do we do stun and Quick at the same time. We don't have to worry about the rest of this.
Yes.
And that's a problem I think that the Quick working group can probably solve in consultation with people who know stun, as opposed to this, which is like terrifyingly complex. And as you point out, you're going to end up with issues of constricting the space or having features that suddenly become unavailable if you're in a peer-to-peer mode. This just is giving me a whole lot of heartburn.
So I think they actually end up being the same solution, which is why I'm talking about it. Because I think the Quick, I think in order to make Quick play nicely with the rest, you end up doing something that looks a lot like this anyway.
But you do it inside Quick. And I mean, they're going to have an extension point for this, right? There is my understanding, there's a way to indicate that what I'm doing right now is HTTP, and you can have a packet that's going to be RTP, you can have a packet that can be, whatever it is that you're trying to slam inside here. And that's architecturally designed, as opposed to something that we kind of noticed happened and then tried to sort of squeeze in around the edges when we realized that, well, what we really want to do doesn't actually fit, but maybe you hit it with a hammer enough and move these bits around, it will.
I mean, I don't think that works. I think that means we end up with Quick only working client server, because it ossifies around a Quick header scheme that doesn't then work with things like stun. And we end up having to reinvent the whole stun thing as a Quick extension.
No, I think figuring out how to make stun work for Quick is reasonable.
Yes.
Right? Doing it so that we fit in with all of these other things, I think is crazy pants.
I think the amount of changes to make stun and Quick coexist, and the amount of changes to make stun, Quick, and everything else coexist, it's one trivial change difference between them.
No, because stun takes like 3 bytes out of this space.
But if you go back a couple of slides. So I mean, what we're doing to keep going back. Yeah, this one. So to make stun coexist, we flip this. We invert the state of this bit. I think that's all we need. If we also just renumber these, which is a trivial change to quick, then we also get coexistence with everything else.
Right, but again, what you're doing is you're giving up features inside quick.
No,
and
no.
You're saying we can't do channels, right? And you're
No,
saying that we can't
with
do
some-
whatever types happen to impinge on our space once they exhaust this range.
No, we're not.
The only change is that we assume that
It changes
you don't
nothing
need
in
the
quick.
connection ID for peer-to-peer. That's the only assumption. That's the only limitation.
Yeah. There is no
Currently,
semantic change to quick.
Zero means it exists and 1 doesn't. So you
Right.
have to flip it at the value. That's all.
Yeah.
That's the only thing, because the assumption is you don't need it.
Sorry.
Okay. So for the first case, there's no change in quick. It's just saying instead of using for the packet field to start from 1 up to go from 7F down. Okay. That's
Right,
the
and then they can define new packet types. And
of course,
run out.
but
if-
they run out only if they need 6 to 1. The second bit,
So,
the 64 will be 1. It will go from 1 to 0. That's the only case where
So-
it will draw.
So yes, the quick people will define new packet types. If they define new packet types and start using them, then they will not be able to demultiplex that along with stun and turn, with turn and RTP and all these other things.
Which
Okay.
is what I said.
No,
Sure,
no,
but
it's not correct.
we don't regard. I don't believe that's a problem. Right. For quick version 1, they're not going to define new packet types. And it's quick version 1 we care about for multiplexing with RTP, because by the time there's more versions of quick, RTP, I expect, will be running with inside quick. And they're never going to get down low enough. They're never going to define enough packet types that it starts conflicting with stun.
I think, first of all, there's the invariant. Adam, first of all, they'll have the invariant part, which says you cannot change a lot of the information because in future version, because you have to have the version in the same place, in the same position for all future versions. Okay, the version which is down there, the 32, just before the payload in the header. The header structure will not change below the version number. So this start will always be the same.
We only care about the top byte here.
So as for the top byte, you see we have the top byte starting with 1 or with a 0. Okay, and all the rest are you can do whatever you want. Now for the first byte, the only limitation that's now being added is that what we're definitely saying that for the long header will start with 1 and not with 1. Okay, that's the limitation there. Okay, so we reduce the number of types that you can have. Message type for the long header to 64 and 63 basically, because those not 0 instead of 127.
So I think you're right, holding Ronnie. For quick long header packets, they are always demultiplexable with stun, because they always start with a 1 bit, and stun uses packets start with a 0 bit.
Just stun.
Yes, just
the
stun.
stun.
Yes.
The stun does no problem at all.
I agree with that.
Can you let me finish, Ronnie?
Yeah.
So the long header packets stun, we have no problem with. That's always going to be demultiplexable. By renumbering the fields, we happen to gain coexistence with RTP and all the other things for quick version 1. And you may or may not think that's important, but for stun, there's no problem. For the short header packets, if we flip the connection ID bits, then we also get coexistence with stun, and that's important. Right, and if we don't, then they conflict with stun packets. So the stun, this is the essential change, and this is a nice to have.
Sure. And like I said, for stun, I can sort of see this. But when we start trying to go further and like we want to have quick and RTP as peers on the same port without anything other than, this scheme is where it starts getting really dicey.
Sure. And from my point of view, the stun bit is the essential one. If we happen to flip the rest and get the rest, okay. I regard that as a win, but I don't care that much.
Okay.
Other people may have different opinions.
Yeah, running event. I cared about, I mean, because I don't see, I mean, we are working on RTP in Quick, but we know it will take a long time because we have a lot of things that we need Quick to change in order for it to work. Okay, so we may still see RTP and Quick running in the same channel in the cases that you described. So, but at least for the way that it's currently described, then if we have starting with 1.1 in the quick long header, then we don't have the problem. Of course, we don't have the problem for the short header for that.
Nils Omer. Yeah, I think this comes down to the question of do we need to support a transitional period, I guess, of like where you can do, for example, for WebRTC, like quick for the data channel, but still use RTP at the same time, right? Like, or if we go like later on, if everything goes over quick, then we no longer need to worry about that. Yeah. But the other question is like, is quick now only the first one of more protocols to come down this path? Sure. So do we need like do we need to wait like I don't know, a registry, a signaling, like some kind of solution to like basically tell me like, oh, this is where look up basically how to demux things coming on in on that UDP port. Right?
Yeah, I mean, ideally there'd be some sort of port identifier and a registry and this sort of thing. But yeah. You know, ideally this would be all running over IP and this wouldn't be an issue, right? So yeah, port numbers.
Harald Alderström. Using the calculator that I used to estimate that WebRTC would take 2 years.
Yeah, right.
I estimate that we will have HTTP 1.1 done by the end of 2018. We might have a quick version 2 with support for RTP rolled out or specified at the end of 2019.
Yeah, absolutely.
And so on and so forth. So it will be a while. Yes. Well, for the case of Quick, instead of SCTP for the data channel, we have running code today. We'd like to have a spec out for it, and we'd like to deploy it in production to see whether it works well. And in order to do that and not wait for Quick version 2, we need to do exactly this demultiplexing. So
we need to do
the whole
demux.
demux thing is a hack. It's somewhere between a horrible hack and a disgusting hack, but it's our hack. So can we just stick with it?
Like it? It's not ugly at all. Yes, I think the nice thing about this is that semantically it doesn't change anything in Quick. Yeah, if you want to demux, then things get interesting, but if you don't, then it's just a regular Quick. We've just renumbered some of the fields.
Ben Campbell is an individual, and a couple things that went by in the line before I got up here that I'm not sure I interpreted correctly, so my point might be moot. But when we start talking about the demuxing of things other than stun, RTP or whatever, and it might be nice, we do it if we're doing it because it might be nice, we might use it someday. I would rather give people guidance to not do it unless we need it, right? That's not what ports are for. That's not what demux is for, right? We do but the demux we have now because we have to. But if there's not a good reason to encourage people to try to share all these things on the same port, let's not encourage it.
So Magnus Westerlund, I think we do need the RTP avoidance, so to say, because as I fully expect that we'll see people in WebRTC be deploying, as Harald says, they're already running code. There will be more than Google doing that. So
I think in the long term we won't, but in the short term, we're short is probably the next 5 to 10 years.
Yeah, yes, exactly.
In the long term, we're all dead.
Yeah. I actually been thinking about this connection assumption. It's probably fine assume that you actually have all the bits, so you can lock on UDP IP address and UDP ports, and not run multiple simultaneous connections to the same peer, which I guess is actually what the limitation comes down to.
Yes, it means you can only run one quick connection onto the same
Yeah.
On the same pipe.
on the same
Yeah.
same UDP ports.
Yeah, but I mean it's
Always do another UDP.
Yeah, exactly. Yeah. So,
Yeah.
so I think that's not an issue. Yeah. because you don't
Yeah, I
have
mean, I was
UDP
thinking about some of these middle boxes, etc. It probably has one start binding port, and then you need to kind of bind up so you use the filter after you've done the ice handshakes, etc. You need to move on. So I don't know how clutch the implementation stage of actually going from a fully open exception or some and then binding it down to a particular remote address. So, but that's,
Yeah, that I don't know. But I think from the quick point of view, I think it's not an issue
Yeah.
that you're only running one connection.
yeah. But anyway, are you considering that we should run the short type field from high level numbers to lower also?
I wasn't considering that.
But I would ensure that in the case you actually need a connection ID, you would still get to those packet types that collides with stun would be coming last in the assignment order.
True, that might be worth thinking about. That's a good idea.
Ronnie, the short header is different from the long header. The whole field is different. The type in the short header is just to mark out what is the if the packet number is 8, 14, or 16 or 32. It's not
We could still define them going downwards, though.
But you have also the K bit there, and we are also considering adding more flags there.
It's a consideration for when doing that, so you ensure that in those cases those bits are 0. The packet type would be a distinguishing factor that would keep it out of the range of the 0 to 3 value that stun uses. That's my point.
Okay, so just but you'll have to define what is the type length currently. And I think that's what you'll have a problem with, because currently the type is 5 bits, but it will be
This
shorter.
is not the quick working group.
Yeah, okay.
We cannot decide the packet formats of quick packets. So.
Yeah. So I think that the next steps, I think, for the quick side, what I propose to do is submit a pull request to the quick spec that makes those 2 changes, and I think that will then be discussed in the quick group, and they will see whether to take it up or not. And talking with Martin Thompson, who is one of the editors of the quick spec, he seems amenable to that, but obviously the group would need consensus that this was the right thing to do. From the AVT point of view, or possibly the transport area point of view, I don't know what the right home for that is. We should consider whether we need to update 7983 or whether this is something quick specific, or who knows what we do.
I mean, 7983 was a product of this working group. I'm not positive it should have been.
Yes. And there are bigger transport issues here, so it might make sense to do that in transport working group by or TSV, or who knows, right? I don't know. But in the short term,
where does the area director think this work should be done?
What does the area director think we should just?
What? No, because if we wanted to do a 7983 BIS, would that be this group's work thing, or should it be something done in transport, or something else? Should we bring it to dispatch?
Not even clear we need a 7983 BIS.
It needs its own area, I think. No, the IEB. I don't know. No,
I mean, you're not
I don't. This is Ben
necessarily-
Campbell. I don't have an answer for that today. I would lean towards, if all we're doing is simply changing 7983, that's probably here. But there are implications that are pretty far wide. So I think some conversations need to happen behind the scenes to give a thorough guidance on that. I think we can assume for now that if the work is done, this is probably the place it would be done. But that if is still a pretty big if.
Yeah. I would suggest we probably need some IETF-wide guidance on whether we are encouraging multiplexing of things onto the same port or not.
Yes, that's
and
kind of what
how we do it if we are encouraging that. But I think that's a separable issue. Then do we just ask the quick group to renumber their bits for now?
We'll keep the sludge going when we figure it out. Yeah. All right, and finally, this is Marvin. Oh, Jen is doing it. Okay. Okay. What? Yeah, this work actually belongs to XR Block, so we can't make any consensus here, but we wanted to discuss and socialize this to get some feedback on whether people will be interested in pursuing it when and if XR Block ever meets again.
Okay, good morning. I'm Marvin's colleague. For people who don't know me, actually, my name is Qing Wu, and I will present this topic. And as chair introduced, this is XR block worker. So next. So in this draft, we introduce a new metric we call the effective loss index. And we also define the XR block report format and to carry this new metric. So this new metric will be used to measure the effective packet loss. Actually, we compare with two existing AVC. One is AVC 7509. The other one is 5725. And we compare the different from the 5725. Actually, this draft that doesn't need to report packet by packet, actually, so we can save this packet by packet report block overhead. And different from the AVC 7509, actually, we more focused on to provide statistics of the total packet loss change, so we can actually predict the packet loss change over the time. Next. So what is the effective loss index? This is a new metric we introduced here. We see this is actually a simple metric to measure the effectiveness of packet loss. Actually, in some other cases, we can actually measure the birthday degree of the packet loss when we apply the packet loss recovery mechanism. And we here give examples. Suppose we receive, for example, 10 effective loss index used through the RTCP XR blocker, and we can actually sort out the 5% RTP receiver who underperformed. So we can actually to make a further action to improve this provide some treatment to improve the quality of experience. Next. So how do we calculate this kind of effective loss index? So we make assumption. So we have RTP receiver, RTP endpoint. They can receive streamed RTP data packets, and we can, for the RTP receiver, they can actually place in the middle box or place in the end host, and they can send a time window. They can actually to apply the packet loss repair mechanism chunk by chunk. Actually, the chunk size can be the time window size, and so you so for each chunks, if for there's some unrecovered packet loss, and we will deem actually this kind of packet loss repair mechanism is effective. So we introduce a formula equation. Actually, for example, we actually receive we can measure the total packet loss with the packet loss repair mechanism applied, and we can compare this total packet loss. Actually, this is more like the pre-repair packet loss. This is something actually has already been defined in the AVC 3611, but it actually is follow long length encoding format actually. So we can use this prepare the packet loss actually compare with this loss effective loss threshold we set actually, and we can actually get the effective loss factor. So we give so suppose we receive 10 chunks, we can actually average this effective loss factor and also multiply 10,000. So we can translate the percentage into the integer to give the more easy way to see this kind of effective loss. Next. So this is a simple example. Suppose we receive 9 packets. Actually, we can actually break down them into 3 chunks. Each chunks we have 3 packets with different sequence number 1, 2, 3, and 4, 5, 6, 7, 8, 7. So in each chunk, suppose we lost 2 packets, but we set a threshold, for example, 1. So it actually is greater than the threshold. We will actually set the effective loss factor as 1. If actually it's less than the threshold, we'll set the factor into 0. So we can actually calculate this kind of effective loss index. Yeah. Next. So this is a new block XR block format we proposed. Actually, for the XR block header, we will actually use the same header we defined in RFC 3611. And in addition, we introduce the new metrics, and it is a 6-bit new metrics parameter, and we have 6-bit padding. Yeah. Next. So to calculate this effective loss index, we need to calculate two parameters. We need to configure, for example, threshold and the chunk size or batch size. We use a different term, maybe a little bit confusing, but we think maybe chunk is more better. So we can use SDP to signal these 2 parameters. And actually, this is the only. This is one way. We may use some other out-of-band mechanism, or we just manually configure to configure these 2 parameters. Next. So there's some discussion in AVT core mechanism. I didn't follow that, and my colleague actually follow up. So we have 2 considerations for these 2 parameters. One is effective loss threshold. The other is the chunk numbers. For this threshold, we think, as we already discussed in the previous slides, we can use STB to signal this kind of parameter. And but for threshold, how to set this threshold? This is based on the RTP application. For example, FEC application, you may consider the FEC the coding mechanism or coding rate. And here we give a simple example. Your threshold can be set as the number of the packet in the FEC stream. So for the chunk of the number of chunks, actually, this is we believe actually the more number of the chunks you receive, the more accurate you can get this report value. So we suggest that you set the greater value for this effective loss index. So this summarizes the discussion on the list about these 2 parameters. Next. So that's all. Yeah, we like to solicit some feedback and comments on this.
Anybody wants to comment now on anything?
So Magnus Westland, how well established is this metrics? Is it a new metric, or is it an existing actually used in the measurement community in general?
Actually, that's a good question. Actually, we thought about this. We discussed with our colleague. Actually, this look like this is a new metric. Actually, they can based on the existing metric defined in RFC 3611 and also the other 2 post-repair packet loss metrics, you can derive this metric. It's more like a pre-repair loss. Use this pre-repair loss count to compare with the threshold we set. So this pre-repair packet loss, you can get calculate this based on the loss wrongness encoding that defined in RFC 3611. In addition, there's another job that actually is from Rocho and some other colleagues. They define the post repair loss counter. They define two parameters. One is post repair loss counter, also repair loss counter. So you can sum all these two parameters together. You can get this pre-repair packet loss. So this is a new metric we introduced here. Yeah.
And obviously, as an individual, since it's not my working group, the one thing I would say is that since it's a 16-bit field, I would have your multiplier be 2 to the 16th rather than 10,000. But that's trivial.
Yeah. I haven't thought that. Yeah. Maybe we will figure out this.
So any other comments on this? Take it to the XR block working group mailing list. And other than that, anybody have any other business, or do you have some comment on this, Colin, or something else for
No, I was just commenting on this. I mean, it's. I mean, I'm not a measurement guy, but so I can't comment on whether it's useful. But it clearly fits the architecture. It doesn't cause any harm. We have plenty of space, so there seems no reason not to do it. Although whether it's useful, I cannot comment.
Thank you.
All right.
Okay. Okay. Thank you.
And anybody have anything else you want to discuss in AVT Core? If not, we are done. And oh yeah, where's our blue sheets? Everybody signed the blue sheet? Hopefully the people who left early didn't. What? That's true. Good stuff. And other than that, make sure everybody signs the blue sheet, and we will see you. Well, I personally will see you the rest of the week, but as a working group, we will see you in London and on the list.
I have some more important comments. Feedback. You can't really I was wondering if you want to discuss this, or that we will go through them and you write up your own work section. Should be put forward also. Yeah. Jonathan, you call them from the Etherpad, do you notes?
I can, yeah. I have not yet. That's...
Yeah, no, but I don't need to send them to you.
No, I can get them from there. I mean, email me to remind me you put them on Etherpad.
What?
Email me to remind me you put them on Etherpad.
So, Colin, I have some more editorial comments on feedback drafts. If you want to go through them. Yeah, rather than like typing them up, so these that we discussed before, I said we enjoyed
Actually, I had one sort of, I think I mentioned this to, I had sort of a thought about the format of it, in particular. So it occurred to me, no, the format of the packets, yeah, with something actually technical. So it occurred to me that the way you're doing, all timestamps relative to the send timestamp to feed